Hi everyone, and thank you for joining us today. My name is Joe Farruggio, and I'd like to welcome you all to our roundtable discussion on navigating the off-grid challenges in Australia. Now, before we start the webinar, I'd like to remind you that you can submit a question at any time using the chat box you see in the webinar window. And we will be logging these questions and we'll respond to them as many as possible after the webinar via email. So kindly note that the webinar is recorded. The recording of the webinar will be sent around in the next few days for playback. Now, off-grid projects are regularly capturing the headlines here in Australia, and this has been driven by a growing number of export projects being proposed, and not least their sheer scale of these projects. But it's also being fueled by these corporate net zero goals and announcements, in particular the mining firms seeking to build these utility scale projects to power their own operations. And here at Rystad, we're tracking over about 350 gigawatts of solar, wind and storage projects in Australia alone, and about over half of this amount is associated with off-grid projects. So the potential for investment and jobs is huge. But what are the challenges associated with developing these projects? So today I'm joined by some of the leading players in developing off-grid projects: Total Eren, Jacobs, Bechtel, Longi and Nextracker. So with that, I'll hand you over to our panel and I'll ask each of them to introduce themselves, their company, and to share what excites them most and the opportunities off-grid projects present. And we'll start with Maria at Total Eren.
Hi everybody, thanks for inviting me to this webinar for off-grid projects. So my name is Maria Bathcase. I'm the technical manager for Total Eren, covering Australia and all the Asia Pacific projects. I've been part of the company since December 2019, and it's been for the last 2 years, I have been able to see the transition within the company moving away, not moving away, but incorporating or moving towards the decarbonization plan within, and the incorporation of new policies and targets within the company. So at the moment, Total Eren has a target of globally of installing or actually being the renewable energy projects up to 100 gigawatts by 2030. And Australia, big part of those targets will be focusing on green hydrogen projects and these mega scale projects, which put Australia in a very good opportunity because we have been blessed by access of land and now good wind and solar resources. So part of these targets is to focus a lot on development on of this green hydrogen across Australia or participating on projects with partners, etc. And not just here, but obviously globally, like Chile, with the technical team, the engineering team in France is involved. So, well, from Australia, yeah, we have been investigated access for the last 12 months, and that's going to be a big part of our tasks from these years to come.
Thanks, Maria. Colin, would you like to go next?
Yeah, thanks very much, and thanks for the attendance. Colin McCullar from Bechtel Infrastructure. I'm the company's renewable lead for Asia Pacific in its infrastructure business. I'm based in Sydney. I joined Bechtel in the back end of 2020, start of 21. I've had multiple years of experience delivering turnkey projects. I've delivered over 1 gigawatt of solar, 400 megawatts of wind, and some large-scale batteries, amongst other major infrastructure projects. Bechtel in Australia has been in Australia for 65 plus years, and we've executed over 180 projects in that time, and most of which are very large-scale projects. Globally, the business has carried out over 225,000 projects over 160 countries and seven continents. So a large global business executing large EPC and delivery partner projects. What excites me about the off-grid projects in Australia is the size. You know, we're all understand that these are going to be large, complex projects with large interface issues and concerns, and that's excites me as an individual and business within Bechtel, because that's the type of projects that we thrive on as a business.
Thanks, Colin. Ben, would you like to go next?
Thank you, Gerald. And first, thank you very much for having me on your webinar. My name is Benjamin Wong. I'm with LONGi. I'm International Marketing Director, joining LONGi about 3.5 years ago. It's a quick introduction of LONGi. LONGi has been founded in year 2000 and is today one of the world's most valuable energy technology company in the world right now. And for this webinar, to talk about off-grid has been an honor and a privilege. As a sector, the off-grid sector on a global sector is not large, but it is growing. And as Colin has mentioned, it presents its own set of challenges. First, on the panel itself, in terms of reliability and in terms of performance. And second, it presents challenges in integration, as Maria has mentioned, towards battery, towards hydrogen and all. I'm very excited to be in this panel and looking forward to our robust discussion. Back to you.
Thanks, Benjamin. James, over to yourself.
Thanks, Jero, and thank you to Rystad for the opportunity to be part of this panel. It's James Butcher. I'm the senior engineer with Nextracker's Australian team, and I lead the engineering group for Australia and Southeast Asian projects. To give a little bit of introduction to my background, I come from a geotechnical consulting background, but I've been involved with some of the first solar farms in Australia back to 2010 on Broken Hill and Moree, and have been with Nextracker for the past 4 years. In terms of what, well, firstly, for those not so familiar with Nextracker, we're the leading global supplier of solar trackers. Within Australia, we've been here since 2015 and hold the market leader position, and with approaching on 90 projects within the country. Globally, it's more approaching now in the range of 60 gigawatts of total projects that we're delivered or in the process of delivering worldwide. So, we very much like to see ourselves as the leader in terms of tracking technology globally, and looking forward to continue to provide that within this new and exciting project space. And so in terms of what really excites me about this space, I think that like Connell has touched on, scale is something which it's kind of hard to wrap our heads around in terms of transitioning from a 100 megawatt project to a 10 gigawatt project. What that tangibly means in terms of almost every stage of that project, from design, construction, and asset management, how the technology can support the project being a success. And so for us, typically these projects are in some remote regions subject to aggressive environmental conditions, which also are going to create their own challenges for these projects as well. And so I think that it's going to be a transition of mentality coming from a Australian East Coast grid connected market, with the largest project we're looking at upwards of about 500 megawatts to off-grid multi-gigawatt scale that's just going to present its own exciting opportunities and challenges for sure.
Thanks, James. And so finally to you, Donny, to introduce yourself and what excites you the most in the opportunities that off-grid presents. And actually, while you're there, Donny, why don't you just help us define a little bit by what we mean by off-grid in this context?
Yeah, thanks, Joe. Pleasure to be a part of this panel. So I'm Donny Richmond. I'm the New South Wales team lead for generation and energy storage. I've been working at Jacobs off and on for about 12 years, and with renewables, I've worked probably for the last 10 years on solar and wind, mostly. For those that are unfamiliar with Jacobs, we're a cross-disciplinary engineering firm and consulting firm. And we work across many industries. We're about 70,000 plus employees worldwide. But we have a very large group of engineers within Australia that support power industry. And so we're very committed to providing support to our clients with the clean energy transition. And the off-grid, as you mentioned, Jiro, what excites me about off-grid is the fact that no two off-grid projects are the same, and that makes it for a very good challenge for us engineers. It also means that it requires generally more specialist type resources and engineering resources to support the project. We will typically be supporting owners and developers of these projects, small or large. We also consult with the regulatory bodies and the policymakers, and so there's a varied. We have a very, I guess, the stakeholders that we work with are quite varied. So with off-grid, your question back to you, Jared, the question about off-grid, it's very unique to Australia because in most other parts of the world, off-grid is usually associated with smaller projects, but in the case of Australia, off-grid can mean quite large projects, and so I think that's what makes this conversation so well timed with so many projects in the development pipeline and such a good range of people on this panel to speak across those projects.
Thanks, Donny. So look, just to summarize, then, so the opportunities again is the size, the scale. We talked about that. I think the point that was mentioned is a great one, that it's not significant at the moment, not in Australia or globally, as Benjamin said, but really growing, and that potential is really there. And then, of course, off-grid means you're not associated with the NEM, which presents its own opportunities and a positive at the moment, with grid connection being some of the big challenges here. But let's talk about the challenges. A couple of you touched on some of the unique challenges that off-grid presents. So we'll go back to Maria then and again and say what are the challenges that off-grid presents?
At the moment, at least from our perspective as Total, now that we start investigating, or the last year, we've been getting ourselves into this process. It's multiple things, but one of the things at the moment is obviously, one, given the scale of the project, we have to make sure that the land security and making sure that you just target the perfect location, and then from there you expand. So the time and understanding the process for day one is crucial. And because again, securing 100 megawatt project, you just speak, but now you have to expand to beyond that. And all that process takes, it's a quite complex scenario and exercise that it takes a while. And then from another perspective, from my side is technology, like Jen said, we are trying to understand the puzzles of hydrogen, understanding the economics and the risks of those projects based on technologies and assumptions that are made on now 2021. But although these projects will be delivered in 2025, 2030, just because timeline we're developing today, but construction won't start. The delivery phase it will take a few years from now. So we will constantly evolving and updating the models in order to understand, because the economics of it. So at the moment, we're just trying to juggle the different risks. And my role as a technical, I try to work on the work today and de-risking all the projects along the path. And at the moment, it's full of assumptions and not enough clarity. And some of those locations is suitable. Okay, we have the infrastructure, but how, if we're going to install the solar panels in there's a lot of projects, WAs, Wind Region D, we're going to, now we have like a suitability of the technology in those locations. So I've been quizzing James and then with Longi. So we've been in that level of partnership, and I think it requires incorporation and the involvement. We have to work together on the aspects for me. So I try to gather information from the technology supplies for me to come up with at least suitable design that we can start model, and the combination of wind and solar, so it creates an extra layer of the hybrid system into hydrogen, and then understand how many access to, again, all the forms of energy consumption that the hydrogen plant will require, and make sure the upstream side is perfectly sized to supply the energy requirements. So
thanks, Maria. No, some good unique challenges there. Conal, do you want to expand on some of those challenges?
Yeah, I think, look, if you put the technology to one side, that is Maria touched on the complexity of the technology. I think execution, from an execution perspective, there's going to be some extreme complexities there with respect to, everyone's au fait with how we're putting together 100 to say, let's 400 or 500 megawatt solar farm or a smaller wind farm. You get into 2 gigawatt or plus solar farms, you need to have automation in every aspect of your delivery of the project. That's from piling through to tracker installation and module installation. So I think the focus is going to be on how the automation will come into play with the technology. Technology on its own is not going to be the right approach here to install these projects with security of delivery. So that would be a complexity, and then the other complexity I would say is around the capability set of the current market with respect to installation of that. There's very few contractors with the sheer size and scale to be able to take on a project of these size and natures. So I think the way that these projects come to market and the way that they interact with the EPC contractors that can deliver something of this size and scale and interface complexity will be something that needs to be reviewed. You're not going to be able to have a competitive landscape like you would have for a 100 megawatt solar farm, as an example.
That's a very good point, Colin. I think that especially when you're looking at some of these projects alone are looking to develop in 1 year what the entire country has done in solar historically as well. We're talking about a different level, and I'm sure we'll get into the mitigation and dig deeper in that later in the discussion, but we'll first pass to the rest of the panel just to outline what they see as the complexities associated with these. Thanks for that, Colin. Ben, any other complexities associated with these off-grid projects? I think you're just on mute there, Ben. But
from a module manufacturer's point of view, I think the complexities may not be as challenging as those described by Maria and Conal, but we are looking at a crossroads right now between the large format modules based on the M10 standard and the over large side, let's say, based on the G12 standards. And that presents, I'm sure, different challenges in terms of design and integration, especially also to the next tracker. And perhaps James could elaborate a little bit more on that. The other part of consideration in off-grid, especially in a very harsh environment, is heat performance. And that part, you need to start looking at degradation of the panels over exposure to high heat over long periods of time. Okay, and second, the heat coefficient of each of the panel. So these are the factors we start looking at in terms. Third factor, which is also important to look at, is performance under dynamic load. Dynamic load relates to wind, not static load. Most modules are tested based on static load, where you just have a weight sitting there. Okay, it's much more important to look at dynamic loads in terms of wind performance, particularly in off-grid situations where you have wind pushing it at different times. So LONGi in module testing in a lab, a certified lab, I believe in China recently, tested a module at 1,500 Pascal at 5 Hertz, which is about 12 compression per second, per minute, sorry, 5 Hertz, and up to failure, and it took up to 22,000 times, okay, before you see failure in terms of, or not failure, but in terms of micro cracks showing with EL. Other modules, large modules, actually performs much worse. Okay, right off the scale, in fact. Okay, so we are happy to share those studies with our customers and anybody who's interested. So just to recap, the challenges of size, the challenges of heat, and challenges of wind.
And thank you, Ben. Excellent, and especially in some of the locations that these projects are being proposed. James, anything to add?
Yeah, I think there's some really great points that have been touched on there from the last three panelists, and so just to step through them one at a time. So from Maria's points around these mega project locations, typically they need a pretty good solar and wind resource, access to a port, as well as a community or a labor force, and so that means that most of these ones that we're looking at are on the sort of northwestern or northern coast of Australia. And as Maria mentioned, those are region C and region D in terms of wind classification, and so cyclonic wind classification for both those locations. And so that creates its own complexity in terms of being able to design tracker to withstand those cyclonic wind events. And it's not going to be something which is theoretical, because these are the northwestern coast and offshore. The warm waters within that part of Australia is the most cyclonic prone part of the country, where I think we see something like 5 cyclones develop on average offshore, and 2 of those cross the coast, with one of them being severe every year. And so we need to be comfortable with the technology aspect, as well as consideration for construction, and as well as the operational period of each of these sites, that they will be subject to cyclones at some point during their project design life. And then as well, what Maria touched on is that we're looking at project delivery timelines instead of sort of 1 to 2 years of what we're used to. It's more like 5 to 10 years and beyond for these projects. And so the technology that we select at the start of the project will change throughout the project construction timeline. And I'm sure Ben is all too familiar with the changing module market, which has created enough challenges for us as it has been over the past couple of years within the normal utility space. We're now moving to project scale of 10 times that size over multiple years. And so, having systems which can potentially be flexible for changing module sizes is something that's going to be critical to be able to support for these project locations. In terms of what Colin touched on around automation, I think that's a really interesting point that, I know that that's something which is being worked on from a few different areas, in terms of looking for how labor can be minimized as much as possible, and automation or prefabrication can be adopted. And I think that's going to be a pretty exciting space over the next couple of years to see how that develops. I would say that I think the industry is in a pretty good place as it is for the moment, in terms of the utility space for labor minimization through construction sequencing. So, in terms of our tracker, it's always been designed to be installed as quickly and efficiently as possible, with as minimal labor force required. And one small example of that is that I think that we're still the only tracking supplier that utilizes a lock bolt technology with our fasteners on assembly of the tracker structure. And so that's it's originally from the train or aeronautical industry, with a specialized tooling, so that these fasteners require no maintenance over the project design life. So if you think about a normal utility project, you're going to have millions of fasteners on a 100 megawatt project. We're now talking about a 10 gigawatt project, where you're going to have hundreds of millions of fasteners on those sorts of a project. And even so, something as small as that is going to have a huge impact in terms of construction timing, reliability during the operational phase. And so, I think it's going to come down to every component of these structures when they're being constructed at this scale need to be assessed in terms of suitability and feasibility for application to these locations and this project size. And then yeah, to Ben's points, look, I think that it is a really interesting point of time in the module manufacturing market. And my opinion is that the modules cannot continue to increase in dimensional size beyond where they are at the moment. You know, that's for a couple of reasons around installability, just being able to install panels that are almost 1.5 meters wide by 2.5 meters long is getting to the point where it can't be done by manpower with a lot of ease. And so, you know, maybe that's somewhere where the automation side of things is going to come into it to see if these can continue to increase in size. But you know, we're certainly seeing that customers will start to have or consider that there's going to be construction implications from handling panels that are just that large. Obviously, as well, you know, there's the logistics piece around restrictions on just how big these panels are when they need to be packed into containers and shipped across to the project location. So it's going to be interesting to see over the next couple of years what happens in the module space, and yeah, it's you know, I think that creates its own opportunities around how we think about these projects and how we think about designing and building these projects. You know, I don't think that we can come at it from having, this is what our existing product, or this is the existing product that's available on the market, let's just apply it to these projects. I think that, you know, we need to think about it from the other side. These projects have their own unique requirements, which requires a tailored product offering for them to be the best solution for those projects.
Excellent, thanks, James. So Donny, large panels, extreme heat, extreme winds, remote location, doesn't sound very easy. Anything else to add to these challenges?
Yeah, I do want to add something, and maybe something that people haven't touched on, because it seems like we've got good discussion around the challenges on these off-grid projects, and certainly the ones of scale. And I think I used the example that Australia had about 10 years ago with the expansion of the Pilbara and the iron ore projects out there. There seems to be some similarities with renewables in that these projects are likely going to be in harsh locations, remote locations, places where it's not easy to obtain local labor. There could be some shortfall in specialist skills because there's so many projects going on in Australia that they could be in high demand in other locations. And so, you know, Australia has really great track record of delivering these projects, albeit at the time period 10 years ago, they did have some cost blowouts, and there was, you know, there obviously was some challenges. And I think these things can be overcome. You know, the technology advances that need to occur to kind of automate things and bring down the installation costs, you know, from reduced labor, and that can extend over to maintenance as well. That is needed for sure, and Australia will drive a solution for that. And you know, just like what James and Benjamin were talking about, when I hear about the tracker and the module suppliers, you know, it would be an interesting exercise to see how a module supplier would design a tracker and how the tracker company would design a module. So there needs to be somewhere that they meet in the middle. You know, the modules maybe can't be too large, but again, maybe the largeness, you know, facilitates automation to some degree, right? So, you know, all these governing equations go into it, and it's exciting to see how it's going to all unfold. But certainly, the interfaces between these key suppliers is one that the engineering and consultants want to be able to manage on behalf of the owners. And so we're going to be very keen to follow those technology advances and support our customers in delivering those solutions.
Thanks on that one, Don. I think you touched on a great point that Australia does have a long history in developing these in booms in other sectors. And you mentioned iron ore. We can also touch on the LNG boom and build out that happened over a decade and tens of billions of dollars. Colin, Bechtel were very much involved into that. How much of that experience is relevant here? And let's move on. I guess we've listened to the challenges in mitigating these challenges and overcoming some of these issues.
Yeah, well, look, obviously Bechtel with its experience on Curtis Island, Wheatstone, some of those very large EPC projects have some pretty robust experience around complex projects in remote locations. I think these projects don't differ to that. They're of a size and a scale that requires complex understanding of logistics, as an example. Your logistics and your procurement processes to deliver the requirements on time to the sites is going to be one that comes into play. I think environmental aspects on sites this big, you know, we're always in mindful awareness of a site that's 100 megawatt to 500 megawatt, whether it be wind or solar. You know, the complexities around environmental impacts and Aboriginal sort of type approach as well. If you look at that from anything up to 10 gigawatt size project, that is a very large site, sparse in its nature. So I think the complexities around the mitigation of how you approach that in a remote location is going to be key to de-risking some of these projects. You know, just delivery timeframes, port sizes, port requirements for being able to get the panels, the tracking containers through the ship, through the port in an efficient time frame. They're all complexities that we sort of undertook on a project like Curtis Island. However, this is these delivery requirements will be a lot faster than what was required on something like Curtis Island. So I think the pre-planning, the pre-interface understanding, and the addressing of the complexities around the locations and what's required to deliver is going to be something that needs to be focused on well in advance of these projects going into construction.
Excellent. Thank you, Colin, for sharing those points. Donny, anything else to add on those in terms of mitigating those risks?
Well, there has been some support in terms of I guess improving upon standards within Australia. I mean, where I think that there could be some benefit is that there's kind of an emerging of standards internationally. You know, when solar and wind, for that matter, first arrived in Australia, there weren't local standards, and I think that what could support this I guess the certainty of these projects from a technical point of view is you know, having codes and that aren't that makes sense, that aren't onerous because they're you know, associated with a different market. They're actually specific to Australia. There can be a tendency to actually have an over specification of codes to some degree when you're working across projects, because those codes tend to compete with each other, and so I think there could be a need to kind of again to look at solutions, technical solutions that like again prefabricated solutions that are compliant to local codes. I think that's probably where I think that there's needs to be some improvement. Australia tends to be a smaller market in comparison to the overall global market in solar and wind, and so things need to be really tailored for Australia to meet those codes. So if something can be done at the manufacturing locations, at the locations where these equipment is pre-assembled, etc., to make them compliant, so they're not made compliant within the field, or they require a different package solution, that would be preferential.
Now, let me jump in here. I think Donny brought a very good point earlier. One of the things that manufacturers like ourselves do, and also we work with component partners, for example, Nextracker, very closely, and also we are inverter partners. In fact, in LONGi in USA as well as Nextracker in USA has a very deep cooperation in terms of testing, in terms of actually field research. And one of the things we investigate is the panel size, as you mentioned, and also the panel performance in the tracker in terms of bifacial performance and in terms of how many strings you can put into a tracker. So as James mentioned, as the panel size gets bigger and gets longer, you can only fit in currently maybe 2 panels per string on the oversized panel, the 210 size panel. Okay. Currently we can fit 3 in the LONGi HIMO 5 panels in there because it's based on the M10 standard, the 182 standard, and that actually look towards reducing the BOS bill of material costs as well as ultimately the LCOE. So these are the numbers that we work with our partners to vet and to validate with third-party agencies like TUV Rhineland. I just want to add that point there.
Thanks, Ben. James, you touched on a few of the technical kind of challenges and possible solutions there. Do you want to expand on some of those?
Yeah, sure thing. And I'd just like to add to a couple of points that were touched on there by firstly by Colonel. So in terms of scale and logistics for these projects, and what that means for material production, for construction of these structures and the other, whether it's the tracker or wind turbines or whatever it might be, so at the moment, we're essentially digging up iron ore, shipping it across to China to be processed and then formed into the steel components for foundations and the structure to then be shipped back to Australia to be, put back into the ground, potentially for the same end users who dug it up in the first place and probably not too far from where it was dug up. With some of these upcoming projects. And so, that may well be the lowest cost option at this point in time, but whether or not that's providing most value for, the end user or the local, the state or the country as a whole is certainly something that needs to be considered. And I think that, as Donny mentioned, having material which is Australian compliant and potentially Australian manufactured is going to be a pretty important piece of the puzzle, and that's certainly something at Nextracker which we're looking at exploring opportunities for local production and tailoring it to these sites as well, so that that can ease some of those pressures on the logistics piece, like what Colonel touched on. And to Ben's point around module sizes and the testing that we do, and also back to your earlier point on the dynamic testing, that's something which has really been a critical part of ensuring that the trackers and then also the panels that are on the trackers are designed to mitigate those dynamic wind effects. That's been something which has been fairly poorly understood, in the past, and as part of like a fairly young industry that continues to develop, Nextracker has very much been a pioneer in working with wind engineering consultants like CPP, and then also the module suppliers like LONGi in terms of doing the modeling and the theoretical or wind tunnel test studies to understand how these trackers are going to respond in these high wind environments. And that's something where we continue to sort of advance and develop products which are now being tailored to these large format modules for these projects which are going to be in cyclonic wind locations. The technology solution will have to be tailored to the winds that are going to be passing through those sites. And that's something that there's obviously an upper limit on where that can be designed to with these highest wind zones, but we have a lot of confidence in being able to deliver tracker for region C and region D within Australia for these projects.
Look, it's a good point that you mentioned, especially on the local content and the ability kind of to produce some of this equipment here. I know that certainly the US is focusing very much on its supply chains, and it faces an enormous challenge with its energy transition. And I'll put the question to anyone on the panel here: are these projects, are these off-grid opportunities here, is it enough to kind of stimulate Australia's supply chain when it comes to renewables, and is the government doing enough at the moment to support that side of the business here?
Well, I'll just jump in there, Joe. I think not enough is my first inclination, because you know, Australia has a great opportunity to actually provide manufacturing, and the reason that Australia lost some of that manufacturing capability was because energy became expensive, right? So with the transition to renewables, we can see now that manufacturing might be much more cost competitive, and along with that, certainly that would bode quite well for you know, solutions that you know, again, local manufacturing solutions to codes and standards, Australian codes and standards. And so that would lend itself quite well. But I think what needs to happen is more policy certainty and some incentives. Clearly, that it's been overlooked, and I think that needs to happen for green hydrogen as well. So I hope that's probably a segue for Maria. But I think, you know, we're talking about solar. We should forget about battery storage and wind turbine technology, but we're going to need all three technologies and electrolyzers to go with it, right? So. And who knows? Maybe there's going to be a huge rebirth in manufacturing, and that's a direct result of just the you know, the solar irradiance and wind resources that Australia has to offer.
That's a good point, Dan. We see this globally elsewhere, and if we take, for example, the offshore wind industry, which, you know, we don't have many of those projects that are being proposed at that scale here in Australia, but globally elsewhere, they're multi-gigawatt projects, and where you see those, in particular, say the UK, for example, and you see that local industry and there's local manufacturing and assembly plants popping up. So maybe similar to these big projects here, they can be the catalyst to similar supply chains here in Australia. James, I just wanted to add one more thing on the environment before we move on the environment. We talked a lot about the wind. And obviously the cyclonic risks there. But are there any other weather-related challenges and risks associated with these projects? I think just to kind of, you know, the context here on the East Coast, we're seeing a lot of flooding here at the moment. Is there anything beyond the wind in terms of the environmental challenges?
Yeah, thanks, Joe. Look, I think that there are some you know, unique aspects that need to be considered with projects of this scale, as well as within the locations that they're being proposed. One thing, as Ben mentioned, is going to be, you know, they're pretty hot and dusty locations as well, and so both of those aspects are going to have impacts on performance of the panels. And so in terms of dust or panel soiling, you know, the panels will need to be cleaned to keep their performance up. And so, you know, for very large projects of this size, it's as well as the, you know, the labour costs within these locations, it's there are going to be options like autonomous or robotic cleaning, which would likely be used on these projects at this scale. You know, the robotic cleaning solutions are something which are fairly common throughout the Middle East region, which is subject to similar sort of conditions, but less so in this region in terms of the uptake to this point in time. So, you know, I think that's something which is likely going to be implemented on these projects, where the robots just, you know, they go along or go down tracker roads cleaning the panels. They have the capability to move on to the adjacent tracker road to the north or south, and then continue along and to clean in that manner. And, you know, there's similar autonomous and solar powered, you know, little vegetation units that might just, you know, they might be used instead of the typical man on a mower out there going up and down between the rows. You might have robotic lawn maintenance or vegetation maintenance that just rove around the site being powered by the sun as well. In terms of the heat, I think that's something which is going to be worked on so that it can be better understood when being applied to projects at this scale. We haven't really done or seen the results of the potential heat island effects, which could impact projects when you just have such a large developed area with panels. And so I think that understanding how that is going to occur on these sites and potentially looking at mitigating those effects is going to be something which will need to be considered as well. In terms of mitigating other risks, I think that in terms we're thinking about design and the construction stage, but the projects are going to be operational for 25 to 35 years as typical, and so within that operational stage, having the right systems to be able to monitor the sites with ease and remotely where possible and with minimal labor force is going to be something which is going to be critical, and that's something which we at Nextracker we have some really good options around software monitoring of the systems which we're able to do on an individual road basis with our trackers. And so that means that every couple of minutes we get dozens of data points from every single tracker row in terms of how they're performing across an entire site. And so projects getting 100 times bigger, having those sort of software systems to be able to identify any issues and be able to communicate to site teams where they need to go out and fix something up is going to be a really key part to ensuring smooth operation through that asset management stage.
Thanks, James. Conal, James touched on a couple of things there, the remoteness again, and also the labour challenges associated with the ongoing maintenance of these projects. Key challenges as well with the build of these, in particular when we look at these historic boom times in other sectors as well. How's Bechtel planning to kind of manage some of those challenges during the build-out phase, Conal?
I think it's around how we engage in the process leading up to financial close. I think it's how the risks are addressed together collaboratively with the developer or the end client. I think that's critical to the success of the installation, and I say that on a couple of areas, especially with the solar farm. If you just take that as an example, flooding. How are we going to mitigate the flooding? What's the flooding aspects going to be of the project? How is that going to be addressed? 1, 2, geotechnical on a site of 10 gigawatts. How are you going to address the geotechnical constraints on a project of that nature to get your head around that risk? That can only be done in a collaborative process given the size of the project, and it's critical to the success of the project of how the installation will flow from piling into tracker install. Not only that, it's the type of land and the undulations of the land. I know that most tracking devices have an undulation or a gradient requirement that they can be installed successfully on, but if it exceeds that, how do you address that on such a large scale project? So that those key complexities and those key risks, in my mind, need to be addressed up front and have a clear risk allocation and risk understanding and approach to mitigate that up front.
Thanks, McCullough. Maria, I was just going to bring you in on that. We talk a lot about the technical challenges here, but what about the economic and the financing challenges? Anything else in terms of that design and pre-design stage on the financing side? Any specific challenges there?
I was thinking of that at the moment because at the moment, for example, for a smaller scale projects, we finding challenges at the moment to work out on the price availability. For example, on the modules at the moment is a big issue, which is affecting the solar industry. And this is something that this is for projects trying to close a contract, for example, with a panel supplier, either for a small project that we want to secure in 2021, so for 2022, for example, with the large. So how can we forecast in terms to work on the financing of a project for the long term? How can we forecast the price variability over during the construction period? and how that we can estimate that aspect into it, just in equipment. And we're focusing a lot on like the importance of local content. But as I think Donny and Colin said, that the importance of that at the moment, the local content incentive is driving prices up. So we're moving away from the target of our target for at least for me, we're looking forward for the green hydrogen project in mesa scale. And the target is to have this $2 per kilogram. So having this price volatility and if we cannot be able to forecast that, all the challenges and barriers provided by the lack of policy is moving away from that target, or is delaying that target even more. So if the target is to have that price to 2025 to 2030, I'm not sure if we're ready there. So modeling down the financial model at the moment is incredibly hard. And I don't know what solution could be besides just trying to lobbying or trying to support or insist and put pressure and to provide fixed policy on Australia basis. At the moment, the work has been done on a state level, and maybe if we keep working on the state level, we will continue that path, but not sure if all the states in that path. And then how can we forecast this price variability, especially on the module aspect?
Well, it feels like we can't let that pass without bringing Ben on that point. You touched on green hydrogen, and we'll come back to you on the green hydrogen specifics in a second. But Benjamin, costs need to go down, but they continue to go up. Do we have any good news on the horizon for the other players in the room here on the call?
That's a bit like gazing into a crystal ball, isn't it?
Sorry, Ben, I needed to ask this one because.
Okay, well, I can make an educated guess. Okay, well, from industry for about more than 10 years is if you look at this recent unprecedented rise in the prices and you break down into different components, you see that this is driven by a few items converging together all at the same time. The first is polysilicon. Okay, the cost of polysilicon. The second would be the cost of logistics. And I think you also have some impact with terms of the exchange rates between the US dollars, which most trade is denominated in our industry, and the Chinese yuan. But the biggest impact, if I look at the data coming back from is polysilicon. I think from January to September, I think we are looking at an increase of over 36% in the price, of even more than that. Okay, and this has to do with two items again. One is the shortages. Currently in 2021, if I just look at the notes here, the production is about 550 to 600 kilotons of polysilicon in 2021. That translates to about 180 to 190 gigawatts. Technically, that should be more than enough to satisfy this year's demand. The problem we have is that we have production that is all biased towards the second half of the year. Okay. When all projects in the first half of the year was delayed and postponed, and you cannot have a very low production load in the first half, and then everything comes to the second half because you don't the producers do not store polysilicon. So that has created a shortage of polysilicon. But this shortage is going to be hugely elevated in 2022 because we're going to have well, from 550 to 800 kilowatts ton coming online. So over 250 kilotons coming online. So in 2022, you would have 260 to 280 gigawatts of polysilicon available coming in from various new producers. And that's going to bring the cost of polysilicon down, and subsequently, of course, way downstream to wafers to cells and on to the modules. It's not going to happen over quickly in Q4, for sure not in Q4. I think we see some of the effects towards the tail end of Q1 and flowing into Q2 next year. The second part of polysilicon cost increasing is also the China power shortage that brings another layer on top of the price increase. Okay, because China has required that high energy or energy intensive plants shut down the power, which reduces the cost, which reduces the production capacity. That has been elevated at the moment. And as we see the winter coming to the end, well, it's coming in the winter at the moment, but we get into the warmer months, that's going to be hopefully they'll be at the back of us. The third is the COVID-19, which impacts logistics. I think we have 30% of capacity taken out in the logistics transfer, and which has increased the price dramatically. I don't have the crystal ball to this one at the moment. This we see. So
I certainly think so. In Q2, I think certainly for the grand scheme, for all the projects we're talking about, the scale, the ones we're doing, that sounds certainly near term enough, and you have a little bit of leeway there.
Correct.
And no doubt that there's enough projects. I think we're saying there's about 50 gigawatts of projects globally that are at risk of potential delay or deferral as people may defer for a better module price between now and then. But certainly for these off-grid ones, that's certainly enough time frame to see a much more softening, in particularly leading into the design phase of some of these projects. Thanks for that, Ben. I mean, Maria, you touched on green hydrogen, and before we kind of round up the session, is there anything else specific or unique about the green hydrogen projects and integrating these renewable projects in the production and the electrolyzers?
It's the marriage of the upstream with the downstream side, and that's what I was at the beginning of this forum. I was saying, like, for at the moment, for example, my experience is mostly on the wind and solar aspects. I'm learning on the downstream side and relying a lot of the experts in terms of technology evolution on the electrolyzer, sizing, energy requirements, what's required in terms of water, is near the coast for the salinization process. So all trying to figure out all the energy requirements in order to size properly the upstream and how to design the conceptual design upstream, downstream, where to collocate each aspect to keep just to get like an efficient design. And but I think also there are aspects that I still know I'm aware or I need to understand better. Environmental impacts, if it's desalination water, and so what you do with the brine, yeah, and then the safety factors. So there's a few aspects that I'm not very familiar yet, and we're working towards that. So, but for me, the challenge is marrying upstream with downstream, making sure that we design the wind and solar to develop enough energy required for the to producing of X tons.
Yeah, high utilization rate. Yeah,
and then they use it. Yeah, if it's for exporting reasons, if it's for fuel stations, so the end product, it changes the design requirements and parameters. Our main goal at the moment is with the idea of exporting. So therefore, this is mega scale projects. It's crucial, and so the downstream is just you're learning different technologies at the moment, which is still my area of expertise of electrolyzers, and I'm even a chemical engineer, but it's been years. But
well, it's new. It's all new technology, isn't it? Yeah. So it's all very much been done on a much smaller scale before. Donny, I'll just bring you in on that one. I mean, Jacobs have done a fair bit of work looking at these kind of proposals in recent years. Any particular challenges that you see on the green hydrogen side?
Yeah, I think the green hydrogen is well, let's say it's been in the hydrogen economy has been talked about since I was in university. They talked about a hydrogen economy, and so now it seems to be that there's quite a bit of traction and a lot of people thinking that it's around the corner. So I think with green hydrogen in particular, if you, I think the key kind of thing to keep in mind is that it is a transition. So it might have a bluish hue to it because the entire supply chain isn't green, and so it always helps to have a grid connection. And I think, you know, if there is a green hydrogen project that takes off, and that'll require an early adopter, it's probably going to have a little bluish hue to it. And it's probably the key thing to consider is you know, you have to have a backup power supply solution potentially to, you know, to make sure you have a high load factor, capacity factor on the electrolyzer. So you know, there are some considerations that need to be made to improve the economies. But as battery storage prices come down, well then you can probably remove blueness to it. And so that would be my key takeaway. And doing feasibility studies, or Jacob's doing feasibility studies, we've seen those costs, forward-looking costs come down, and so that definitely changes the equation. But keep in mind, it is a transition, so it might not be immediately green. Yeah.
And that might be immediately green, a kind of a blend. Well, look, I think
Yes.
the fair thing I'd say is it's a great point, but the hydrogen economy and the hydrogen side has moved incredibly quickly in the last 12 months. It's actually quite exciting to think where it could go in the next 12. So thanks for that, Donny. Look, I think we'll just give everyone the chance to give their closing comments now. We're just over the hour. And as you kind of give your closing comments, maybe share with everyone on the call your opinion into how many years away is a gigawatt or a multi-gigawatt solar farm in Australia. And Donny, why don't we start with yourself?
Yeah, multiple gigawatts. Certainly, that would be, you know, one project. There's lots of locations in let's say New South Wales, the renewable energy zones, where there could be 1 gigawatt but multiple proponents, right? So this is really 1 gigawatt off grid we're talking about, and I think it just comes down to delivery partners, right? You know, choosing the right delivery partners, having all the stakeholders aligned, and the financiers would tell you cost of capital is an important equation in that. So hopefully a low cost of capital to get these projects financed, but certainly no technical barrier. And, you know, within the next 5 years, certainly. Yeah.
So we're talking about, I should have stressed how far before you think they first break ground on a multi-gigawatt project. So within 5 years for yourself, Donny, Maria?
Yeah, I'm hoping that within 5 years we're in that right track. At least, I mean, these projects won't be delivered, will be in stages, let's say. So let's say the first stage of the multi-gigawatt project will be within the next 5 years.
Excellent. James?
Thanks, Jero. Yeah, look, I think it's a really exciting space to be in and pretty exciting times with what's happening in the industry. You know, I'd just like to thank the other panelists who have been here for this discussion, and, you know, looking forward to working together further as things continue to advance. From my mind, in terms of off-grid gigawatt scale project, I'm going to go out there and say 2024 is going to be his first boots on the ground, but it's not going to be a hydrogen project.
It's getting closer.
We're
down to a couple of years. Is it going to be your, Connor? Is it going to be your project?
Oh, Big tells me bound to be part of one of them, I'm sure. I think there'll be multiple coming up, but I would agree it's probably 2024, 25, around that time frame, I would say.
Thank you, excellent. And Ben, finally with yourself, I mean, in addition to when you think the first project is, I mean, maybe share with us, as long as you're currently supporting projects that scale anywhere else globally, either gigawatt or multi-gigawatt projects?
Yes, certainly we have seen large projects in China and the Middle East and some other, also USA, of course. Okay, they all have multi-gigawatts projects ongoing at the moment. But we are in Australia at the moment. We're talking about Australia, and it's actually really great to see Australia getting traction. And I think Connor is also very familiar with the Asia-Australia PowerLink project at the moment. You add that up, that's close to a gigawatt, or it is a gigawatt at the moment. Okay, so perhaps the timeline towards 2014 would be a ramp up, but we really see the curve slowing coming up there, and that gives me great pleasure, great excitement to see Australia pick up so quickly this off-grid of this multi-gigawatt scale.
I like the technicality there on Maria's point that the first phase of the multi-gigawatt will be by 2024, 2025. So maybe that's a good place to leave it on that one. Thanks for that one, Ben, as well. Look, I think that kind of brings us to the end of the time period here. Again, I'd like to thank everybody on the panel here today. Longy, Bechtel, Jacobs, Total Eren, and of course Nextracker. And thank you everyone for listening to this roundtable. It's been a great discussion. And again, just a reminder that we'll get back to you on your questions via email, and a recording of this will be emailed and made available to everyone registered over the next couple of days. Thanks again and good day.
Thank you.
Thank
Thank
you.
you.
Thank you. And thank you to Nextracker
Thanks
for
everyone. Thank
hosting.
you.
Bye.
Bye-bye.
Thanks.